So good day and welcome to the demo video for hands-on lab number 11. So task 1, we were asked to design a real 74148 priority encoder using logic gates and by using logic leap. So I'm gonna jump into my design here. So as you can see, this is the 74148 encoder IC, in which based on the truth table it is an active low IC. So it is as low input. So as you can see, we have here the inputs here from I0 to I7 and the outputs A0, A1, A2, and the two additional inputs, which are the GS and the EO, which will be reflected in the truth table when we try to test it. So if we try to test the truth table, so at first we can see that this E1 switch here is turned on, and as you can see, the outputs are all logic 1, all from the binary code here to the GS and EO. So this is the output, sorry, and the rest of the inputs are don't care. So whatever input is being reflected by these don't cares will not affect the actual output here. So it is unaffected. So let's move on to the truth table. If EI is low and then all switches are high from I0 to I7, you can see here that all the outputs are on. So it is an active low. So it means 0, 0, 0, and this GS is turned on because that GS goes low when E1 is low. Here E1 is low and any input is low. So as you can see, it does not meet the requirement. It goes high because all the inputs are high based on the truth table. So its counterpart EO, it will go high when EI is low and any of the input is low. So and no inputs are high here, are low here, sorry. So we can see the high input for EO. So if you try to just turn off one output and their respective values become switched. GS will now become low and EO will now become high if any of these inputs are low. So moving on to the truth table, we have here this E1 is low, right? And only I7 is low. So based on the truth table, GS is low, sorry, and all of the bulbs are turned off since this is an active low, right? So these are the values are inverted. This in the binary combination, it is 1 1 1 from A2 to A0. So as you can see, it is turned off because it is active low. So the rest are inputs are don't cares, right, from I6 to I0. So these don't cares will indicate that whatever you do with these inputs will not affect the current output. So this is the technique of the priority encoder. It does not it only prioritizes the based on the level of priority. In this case, this I7 has the highest priority and I0 has the lowest. So moving on to the truth table, what if I7 is high and then I6 is low? So as you can see in the truth table, we can see that GS is low, A0 is high, A1 is low, A2 is low. So as you can see, it reflects on the truth table. We tend to turn on the don't cares from I5 to I0. Don't cares, don't. The output is still the same. Next, what if I5 is turned off? I7, I6 are high. So as you can see, GS is low, A0 is low, A1 is high, A2 is low. So don't cares, the don't cares are from I4 to I0. It does not affect the output. So moving on, I7 is low, I7 to I5 is high, I4 is the only low. So based on the table, GS will be low, A0, A1 are high, A2 is the only low. So from moving on the don't cares, from I3 to I0, don't cares, so they're not affecting the output. Next, in the table, we have here I3, I7 to I4 is high, only I3 is low. As you can see, based on the table, we have here GS is low, A0, A1 are low, A2 is high. So the don't cares start from I2 to I0, so this does not affect the output. Next, when I2 is turned off, it's low, right? You can see in the table that GS is low, A0 is high, A1 is low, A2 is high. So from don't cares, the I1 and I0, excuse me, this will not affect the output. So moving on, from I7 to I2, it's high, I1 is the only low. As you can see, based on the table, we have here GS is low, A0 is low, A1, A2 is high. So from the binary code, it indicates that it is 0, 0, 1. So this is an active low. So the values are inverted. So from the don't cares, I0, it does not affect the output. So the last part of the table, we have here, the only low is IO. So all bulbs are turned on because they represent 0, 0, 0, which is the binary combination, and since active low, the values are inverted, and this GS is also low. So that is it for the demo for task 1. I will move on in task 3, wherein we were tasked to create a water level detector using the 74148 IC that created in task 1, and we must display the water level using the 7 segment display right here. So we were tasked to use the switches. So I'm gonna move on to my task 2 here. This is my task 2. So after creating the IC, right, the 74184 encoder, I created this 7 segment decoder using references from the web, and then after checking it, I tried to connect this decoder to the encoder, so that the decoder will display this LED 7 segment LED display that using bulbs. So every segment is an output. We have 7 letters here from A to G. Every segment represents a letter, and we have also 7 inputs. Oh, sorry, these are 8 inputs, right? Because for the 7148 encoder and the E1. So the after the inputs, it will go to the encoder, and after the encoder's outputs will be these 7 segments decoder's input, and then this input will be converted into the output, resulting into this LED display. So since it is based on the real world problems, right, this is the level, water level, indicating water level. So if the water level is not yet high, it's 0, right? So what if it reaches this switch right here? So it becomes 1. So when it becomes higher, moving on to next second switch, it is 2, right? Third switch 3, 4, 4, fifth switch 5, sixth switch 6, seventh switch for 7. So we only display 7 values because that is what we were tasked to do. So based on this real world problem, so if water reaches the maximum, it will display the 7 output. So this mirrors the real world problem wherein the if water reaches a certain sensor, it will alert this LED segment right here. So 3, 4, 6, and 7. So that's it for task 2, and this concludes my demo video. Thank you for watching.